Consider a balloon that has acquired some negative charge, perhaps through friction with another object. There is an imbalance of charge on the balloon. This is a clear example of static charge. Consider an isolated conducting sphere that is neutral, meaning that there is a perfect balance of both negative and positive charges. If we bring the balloon close enough to the conducting sphere, the electric field produced by the charges on the balloon will repel negative charges on the sphere, exposing positive charges in the nuclei of the material that make up the conducting sphere. Notice, however, that no actual charges have been added to the sphere. As a whole, the sphere remains neutral. The charges on the sphere have merely been rearranged as a result of an external electric field. These are induced charges. Consider that if we remove negative charges from the balloon, we could restore the balance between negative and positive charges. In other words, we could neutralize the balloon. However, if we were to add or remove charges from the conducting sphere, that would not restore a balance of charge, since it's already balanced and therefore it can't be further neutralized. So induced charges can't be neutralized in the same way that static charges can be neutralized. Even if the conducting sphere was really big, that might change how the induced charges on the sphere are distributed, but it wouldn't change the fact that no charges were added to the sphere. The charges on the sphere have been rearranged as a consequence of an external electric field. And the induced charges on the sphere cannot be neutralized in the same way that static charges can be neutralized. And instead of a balloon and a conducting sphere, if we're talking about a storm cloud and the Earth, or grounded objects on the Earth, the fact remains that induced charges on these grounded objects cannot be neutralized, collected, dissipated, or bled off.